Hi, in this video we are going to be looking at an exam question which appeared in the contingencies exam a few years ago, subject CT5, September 2013, question number 17. Let's read the question. We're asked to calculate, take note of the notation, IA with a bar which runs across both I and A, subscript 20. So let's just call it IA20. And they have defined that for us as the present value of a whole life assurance issued to a life age 20 exact, payable immediately on death, where the benefit paid on death at time t is t, using the following basis. Now, first, let's make a comment about this question. Note, this is the expected present value. The word expected is missing in this question, so just plug that in. Okay. IA bar, subscript 20, this is the expected present value of a whole life assurance issued to a life age 20 exact, payable immediately on death, where the benefit paid on death at time t is t. Okay, but anyway, even whatever the case, you should know this is an expected present value from the notation, even if they had missed out the word. Good. The basis, mortality mu x is 0.03 for x less than 40, and 0.04 for x bigger than or equals to 40, and they've given me the force of interest. Delta is 5% per annum. Let's talk about the main ideas, how to go about finding a solution to this question. I'm not going to do the nitty-gritties like the by parts and so on, that you can do it yourself, but let's talk about the main ideas. Now, the benefit paid on death at time t is t. So we have a benefit of t, and we are going to bring it back. So let's write, now this is your present value random variable. I repeat, this is your present value random variable for this policy, and we are looking for the expected value, so you need to multiply that by a PDF. So we can write IA bar with an x as equals to, let's write it, TVT, and the PDF of t will be TPX mu x plus t dt, going from 0 to infinity. So this is the formula that we'll be using, and that's what you see written here. This is a solution I prepared for my class. So I normally in my class, I tell them what's the big idea first. So I start with this, where your benefit is 1, paid at the moment of death, and this is for a continuous whole life policy. And I remind them of this, the basic idea, and then I'll just come down to this. Okay, so we have the formula here, which is TPX, mu x plus t. I have my t here, and then I have my e to the power of minus delta t, because we know that Vt is e to the power of minus delta t. Okay, this is the only formula that we are going to use. The problem is we have mortality is 0.03 for ages x less than 40, and it's 0.04 for ages bigger than or equals to 40. So we have a number line, or timeline if you want to call it, that shows the age. This is the age at issue, 20, and then we have got mu x is 0.03 for the first 20 years, and after that is 0.04. So, like I said earlier, we are only going to use one formula. Just be a bit careful here, because t can take different values. For the first part here, this is the case where the guy dies between the ages of 20 and 40, and this is the case where the guy dies after age 40. Okay, so we're going to consider two cases. A person dying before age 40 and a person dying after age 40. Now, so we have two integrals. The point I want to make and remind you of again is the only change, t can take values from 0 to 20 here. And here will be t going t bigger than 20. Okay, great. Let's deal with the first part where this person dies before age 40. So that's what you see here. So let's say this is, he dies at 20 plus t. So if he's going to die at 20 plus t, let's just talk through this. Yeah, if he's going to die at 20 plus t right here, he has to live up to here. That's what you see here, TP20. And then the force of mortality strikes and he's dead. Then you need to pay a benefit, which is t, and then you need to bring it back, discount it. And we are done with the first integral. Again, the values of t going from 0 to 20. Pretty easy, the first one. Then the second case, where this person dies after age 40. So let's call this 20 plus t. Note, t here takes values bigger than 20. Okay. Again, if he is going to die here, or this person is going to die here, he has to live up to here. That's what you see here. And then the force of mortality will strike and he's dead. You pay him a benefit of t and you need to discount it. And you have a second integral. Note the values of t going from 20 to infinity. Now, this is a part that posed a bit of a problem for some of our students, so please take note of the idea. Here, t goes from 0 to 20, and here t goes from 20 to infinity. Okay, let's deal with the first integral. This is pretty easy, okay, because we are going to use the idea that for a constant force model, TPX, remember, is e to the power of minus mu t. So, TP20 here will be e to the power of minus mu. What's mu? 0.03, and we have this. Good. So the first integral is just e to the power of minus 0.03 t, and then I have my force of mortality, which is 3%, and then I have my t, and I have e to the power of minus delta t. What is delta? 5%. They gave me in the question. So I have this integral set out. Okay. So it just, if you clean this up a little bit, you'll get the integral t going from 0 to 20, 0.03 t e to the power of minus 0.08 t. Now this one you can use by parts to integrate, or you can use tabular integration, the ideas you learn in calculus, and work it out to be about 2.23. Good. Now let's handle the second integral, the case where this person dies after age 40. So again, we have TP20 here. We have TP20, again, TP20. So the guy is going to die here, okay? The person dies here. For him to die here, like I said, he has to live up to here. The force of mortality will strike. He is dead. We have to pay him a benefit T, and we need to bring it back, okay? Discount it, e to the power of minus delta t. Now, for him to live from this point to this point, what we're going to do is we're going to let him live for the first 20 years, which is 20p20. Why do we do that? Because the force of mortality is different for the two age ranges. So we have 20p20, let him live up to here. And when he gets to this point, he's 40 years old and he has got t minus 20 years more to go. So I have tp20, I've broken it up into 20p20, t minus 20, p40. Okay, good. So I can just plug in the first part here, 20p20 is just e to the power of minus mu t. Mu is 3% and t is 20. That's easy. And then I have my second force of mortality is 0.04. That's what you see here. And it's multiplied by t minus 20. Now you clean this up, some very minor algebra, and you'll get TP20 as e to the power of 0.2 minus 0.04 t. Once you're done with that, the rest is pretty simple. Plug into the formula. Okay, I plug that in here. Remember, my force of mortality is what? Good. 0.04 t and my discount factor e to the power of minus 0.05 t. Careful, the limits going from t going from 20 to infinity. Now, this integral will also use by parts. You clean it up, you will get about 2.79. All that's left is just add up. Okay, add this up to this, and you'll get your final answer about 5.02.